This is Prashant and welcome to tutorial number 2 for simulation, for simulating this object. And before inserting mechanism and then simulation, let me show an overview that how this object will work after simulation. So going to assembly design workbench to show you how this will work using manipulation. So you can see after simulation this product will work like this. So what we have to do is we have to give revolute joint on arm 1 and base, then arm 1 and arm 2, and then prismatic joint for this cube and this base, and revolute joint here and then here. And I will give only one command, that is angle driven, for this arm 1 with respect to this base. Let me show you one by one. So again, return back to DMU kinematics workbench. So as I have told earlier, before giving certain mechanism to an object, we have to insert it, or we can insert it alternatively. We have to select fixed part for simulation for inserting mechanism. So let's choose fixed part, and if I have not given or inserted mechanism earlier, so the fixed part will demand new mechanism automatically. So clicking on new mechanism, it will create a new mechanism. You can see in application tree. So selecting the base as a fixed part. So this is the time to give joints. You can give it from insert, new joint. There are several types of joints present in that insert toolbar, but as I have told you earlier that, or I have shown you earlier in assembly design, that we need only two type of joints, that is revolute joint and prismatic joint. So I need a revolute joint for arm 1 with respect to base, for arm 2 with respect to arm 1, and then arm 1 with respect to cube, and prismatic joint for this cube and this base. By use of prismatic joint, the cube will move to and fro with respect to the base. So let's insert the joints one by one from arm 1 with respect to base, then arm 2 with respect to arm 1, and so on. So let's choose revolute joint for the first arm and base. And as I have shown earlier that if I would not created mechanism, it will require new mechanism automatically. But as I have created the new mechanism earlier by selecting fixed part as by selecting base as a fixed part, so this joint creation doesn't need any new mechanism. So let me choose the axis of this circular pad, then axis of this, and the axis of the circular part of arm 1, as the arm will circulate around the circular pad. Then choosing plane of arm 1 and then plane of base. See, there are two things, null offset and offset. If I choose a null offset, what will happen? The plane of the arm 1 and the plane of the base must intersect for null offset. As you can see, the creation of the joint is impossible because the mechanism is over constant, as I have told that the plane of the arm 1 and the base is not intersecting with each other, so we can't use null offset. So getting back to the previous position by undo or control Z, so I can't use null offset for this joint, as I have told that null offset means the plane of this arm and this base must intersect with each other, but it is not intersecting. So let's create another joint. Let's choose axis of the circular pad for line 1 and then axis of circular part of arm 1 as line 2, then plane of arm 1 as plane 1 and then plane of the base as plane 2. If I don't know the exact distance between the planes of arm 1 and base with respect to each other, so I can choose offset. It will automatically get the exact value of the distance between the planes. As I have shown you in assembly design that this arm 1 is prime mover and this requires angle driven command, and in a mechanism we must give one of commands to work like the previous as shown in assembly design. So let's choose angle driven command for this joint. As you can see, the mechanism can be simulated for this arm and base joint as I have created, but I have to simulate the whole object. So let me insert joint one by one for arm 1 and arm 2, then arm 2 and Q, and then prismatic joint for Q and base. So let's choose the axis of this pocket of arm 1 and then circular part pad of the axis of circular part of arm 2, then plane of arm 1 and then plane of arm 2, then giving offset and create a joint. So there is no need to give angle driven command here because I have given it earlier. So press OK and let's choose joint creation again for arm 2 and Q for creating revolute joint here. So let's choose the axis of pocket of arm 2, then axis of the pad of Q, circular pad, then plane of Q and then plane of arm 2, offset, then OK. And also one command is left, that is prismatic joint, by which the cube will move to and fro about this base. So let's choose prismatic joint for this cube. Choosing line 1 of the base, and for line 2 choose the line of cube which is attached to the base. For choosing line 2, we have to hide this base, so let's hide it. Then unhide this base, choosing plane 1 of the base, and for choosing plane 2, again hide this base, then choose plane 2 of the cube. So we can see that the creation of the joint is impossible because the mechanism is over constant. So this mechanism can't be simulated. So going to reverse direction, that is going to initial step from where I have started giving mechanism, and then giving commands one by one but in reverse direction. That is first prismatic joint for cube and base, then revolute joint one by one for arm 1, arm 2, then arm 1 and base. So going back, Control Z, let displace this position, the position of the cube with respect to base, by going to assembly design workbench using manipulation so that I can give the commands more easier. Going back to DMU kinematics workbench after displacing this object, let me displace this. Get back to the DMU kinematics workbench. So here you can see that the application tree doesn't showing any mechanism, so I have to insert a new mechanism, and as I have told earlier that we can insert from insert new mechanism, so let me insert it alternatively by choosing fixed part, new mechanism, and then selecting base as the fixed part, then choosing prismatic joint, line of this base as done before, then line of this cube, then plane of the base, and then plane of the cube. And there is no need to give length driven command here because as the arm 1 is the prime mover for this object, the prismatic joint has been created over here. So let's choose revolute joint, then axis of pad of this circular part of cube, and then axis of circular part of arm 2, then plane of this pad of the cube, circular pad of the cube, and then plane of arm 2 and giving offset. And there is no need here to give angle driven command again. Press OK. Again revolute joint the axis of this pocket and this axis of the axis of this, the circular pad of arm 2, the plane of arm 1, then plane of arm 2, and OK. Last joint is left at here, arm 1 with respect to base. So axis of the circular pad of base, and then axis of circular part of arm 1, then plane of arm 1, and then plane of the base giving offset. And angle driven command is to be given over here because until I have not chosen or given any command in a mechanism, and in a mechanism there must be one command to be given so that the mechanism can simulate. So angle driven for this joint. So as you can see, the mechanism can be simulated. The mechanism will simulate as per the command which will I give. Let's hide these constants as it is not needed now. First, simulation with commands. So in this simulation with command pop-up menu, you can see that according to our choice, how much distance it will travel, I can manipulate this. I can give commands as per my choice and simulate this object according to our choice, means how much distance it will move. So there is no need to give any of the command in this blank space as it is showing, because this minus 360 to 360 is okay. So not giving any of the commands, any of the value in this blank space. So no need to insert any value in this blank space, because according to this object the given command is okay. So I have shown it because it will be helpful to you for the further use. As per your choice, you can give value here and you can simulate as per your choice. So as you can see, the command is okay for simulation. For this simulation, there is no need to give any value in this blank space. So going to choose simulation, to insert simulation in this DMU kinematics. So let's choose simulation. So selecting simulation, mechanism 1. So selecting the simulation. Here a pop-up will appear in which you can also give value to create command as per your choice. There is no need to go to simulation with commands and note such values and give in this blank space. So let's insert in simulation previous position, changing the loop, time step 0.02 and then play. It's not simulating, so again cancel simulation, as it is not simulating, so cancel so that it will not insert. Choosing again simulation, mechanism 1, then plus 360 will be extremum point. Then after choosing this plus 360 as extremum point, then insert, changing the loop, previous position. It is most important part for going previous position so that it will work. I will show you how it will work, as I have chosen time step 0.01. So the speed and acceleration of the object is depending upon the time step as I am choosing. So So okay, the application tree, you can see that it is showing simulation, that is simulation has been inserted. So generating a replay to play it in player, it will be easier to play the simulation. So choose replay option from simulation compilation. Replay has been generated. This is simulation player, so let's choose it. So after choosing the player, select replay from the application tree and changing the loop and then play. You can see the simulation is working, the simulation is completed and the player is playing that. So in this way we can simulate an object. Thank you for watching this video. For more updates and for more help, you can mail me at prashantrjd@gmail.com, prashantrjd@gmail.com. Thank you for watching this video.